Our CS284 final project is volumetric scattering rendering. Unlike surface rendering, which assumes that light rays only scatters when they hit a surface, volumetric scattering also takes the interactions between rays and particles in the media into account. And there are 4 types of interactions between rays and particles in general. For the foggy effects, there is no emission, so in our project, we only consider absorption, outscattering, and inscattering. And we use the ray marching method. For light rays shooting from an object, its radiance will be affected by interactions between particles along the ray in the media. By assuming that the media is homogeneous, we can use this rendering equation to evaluate the radiance of the ray. The f function here is named as phase function, which indicates the scattering effects of the media. We can change the parameter g to achieve different scattering behaviors, just like isotropic scattering, forward scattering, or backward scattering. This is our results of using volumetric scattering rendering to simulate fog scene with homogeneous media. We can also change the parameter g. As you can see, with smaller g, the foggy effect is less obvious and the scene becomes darker. In our project, we also design another type of light source, spotlight. And we need to use importance sampling because it is almost impossible for a randomly generated ray to hit the spotlight. Here is an example of rendered image with the spotlight that was placed in the center of the ceiling. We also designed a scene with multiple spotlights with different colors. In this image, the path of each spotlight can be clearly observed. We can also see some grid effects due to the overlap of rays from 2 or 3 spotlights.